This next video talks about temperature. We're going to be converting. No big surprise there, right? In this chapter, we're converting. Yep. But the conversions for temperature can be thought of as being actually easier than the ones we've been doing because they don't use dimensional analysis. Yeah, that one's really hard for me to say today. Dimensional analysis. In fact, these conversions are simply plug and chug formulas, and there's only three, and only one I'm going to ask you to learn. To remind you what this chapter is all about, it's about measurements. And so all measurements have two parts. The first part that we discussed was a number. With that, we went over scientific notation so we could write numbers that are really big or really small much more easily. And then we talked about significant figures, and those numbers are important because it tells us the degree of precision in our measurements. From there, we discussed units, the main SI units that we use, and how to convert between those in the English system and within the English system and within the metric systems. And yeah, we just converted. This section, this video, talks only about temperature and how we convert from one temperature unit to another. To begin our discussion of temperature, it's a good idea to start with what temperature is not. Well, let me tell you, it isn't heat. Nope, not heat, not heat at all. Heat is simply a transfer of energy, and temperature does not does not equal heat. They are not the same thing. Heat transfer talks about energy. And while we will get into a much more in-depth conversation of heat in a later chapter, you should know that heat always transfers from warmer objects to colder objects, never the other way around. Nope. But that isn't the point of today. We're not here to talk about heat. We're here to talk about temperature. So what is it not? It isn't heat. So the next time you hear somebody say, "Hey, would you turn up the heat?" Yeah, they're probably really just asking you to turn up the temperature. So what is temperature? Well, technically, temperature is a measure of the average kinetic energy of all of the molecules or atoms inside something. Yeah, probably clear as mud now, right? We'll take a look at these two pictures. There's little atoms represented by these little red balls here with these little movement lines behind it. Something with a low temperature, and it doesn't matter whether we're talking low or high, it doesn't matter at this point what the temperature actually is. It's just relative low versus high. At a lower temperature, the molecules have a certain speed associated with it. And while I know the definition says kinetic energy, which is defined as kinetic energy, which is the energy of movement, by the way, I'll just abbreviate it, movement. Kinetic energy is 1/2 the mass times the speed squared. Well, if the mass is basically about the same, we can focus more on v, velocity, or in this case, the speed. Well, the average speed of all of the molecules in this lower temperature box, well, that's how we measure temperature. They're all moving at about the same speed, some a little faster, some a little slower. This one's moving a little faster, but on average. Yet the higher temperature, look at this guy. So higher temperature, look at the speed of these atoms. Oh my gosh, you can tell by the fact that their speed lines are longer, they're moving faster. So whether you are touching something or not is not important. The temperature of something is all based on what the molecules inside the object are doing. Since we're talking about temperature, it's probably a good idea to talk about the 3 different temperature scales. We're going to spend quite a bit of time talking about Celsius. That's the one that's really important to to science. And we're also going to talk about the Kelvin scale. We're not going to spend too much time talking about the Fahrenheit scale, but we will have to talk about it a little bit since I'm recording this in the United States and I'm teaching this in the United States, and we're the only country that still uses the Fahrenheit scale, so I'll spend a little bit of time talking about that, but not a lot. From the previous slide, I was talking about the average kinetic energy, and that being the definition of temperature. So you can think of a thermometer like a speedometer. It provides us a way to measure the kinetic energy possessed by the particles inside an object. These are the three different temperature scales. The first one is probably the one you're most familiar with, and that's the Fahrenheit scale, developed after a dude whose last name really was Fahrenheit. The Celsius scale we're going to be using most often in science. It is the scale that most of the world, well, rather all of the world except us, uses. And then there's the Kelvin scale, which is the official SI unit. Now, science will use both the Celsius and the Kelvin scales. They never, ever use the Fahrenheit scale. No, don't do it. So, ladies and gentlemen, I'm sorry to tell you, not only do you have to know how to convert between Fahrenheit and Celsius and Fahrenheit, but also Celsius to Kelvin and Kelvin to Celsius. Everybody else just does Celsius to Kelvin. Lovely, yes? Well, here's some key features you need to know. The freezing point of water. I know, I always say that, things you need to know. Well, the freezing point of water, 32 degrees Fahrenheit. The freezing point of water in Celsius is 0. The boiling point of pure water is 212 degrees Fahrenheit and 100 degrees Celsius. These are 4 separate numbers that you should just be able to spit out because you were told to memorize those. Yay, something else to memorize. One thing you should note, even though in the Celsius scale, the distance between these two appears to only be 100, and the distance between 212 and 32 appears to be greater than 100, the distance is actually the same. What? Right? Think of it this way. The adult then would represent the Celsius scale, and the toddler would represent the Fahrenheit scale. Each one of these people would get to the same place at the same time. But poor little Fahrenheit's got to take a lot more steps to get there than Celsius. It's just the size of the steps that are different. The Kelvin scale, we'll talk about how to convert between these. And the cool thing with the Kelvin scale, this is called the absolute scale, because there's no negative numbers. No negative numbers. It is the absolute scale because 0 Kelvin is the coldest possible temperature. At this temperature, there is 0 kinetic energy going on, no energy at all. So there's no temperature to measure. You can't get colder than this. Deep space is measured at about 1 Kelvin. It is the coldest possible temperature. Note in the Kelvin system, there is no degrees sign written next to the K. Okay? Oh, I couldn't resist. Yeah. We use a degree sign for Celsius. We use one for Fahrenheit, but we do not use one for 0 Kelvin. The Celsius, the coldest possible temperature, is negative 273 degrees Celsius. And in Fahrenheit, it's about negative 460 degrees Fahrenheit. I believe I calculated it at negative 459.59 degrees Fahrenheit, but negative 460 works. To convert between the Kelvin and Celsius scales is almost the easiest conversion ever. You simply add 273. Let me go over these symbols for you real quick. T sub degrees Celsius. This means the temperature in Celsius. So for instance, if the temperature was 20 degrees Celsius, all I would need to do is add 273 and I would get my temperature in kelvins. So 293 K. That's all you do. And it's almost the easiest conversion ever. There's a couple that are actually easier, but we're going to let them go for today. To practice this conversion, Let's take a look. If you had 55 degrees Celsius, how many Kelvin would you have? So to take a look at these two scales. For starters, notice it is simply a shift of 273. At 0 degrees Celsius, we have 273 Kelvin. If something was 70 degrees Celsius, what would it be? You'd simply add 273. So 273 plus 70, if I'm going to write that, 273 plus 70, 3 and a 4 and 343 Kelvin. A direct shift. For every 70 degrees Celsius, we have a shift of 70 kelvins. Let's look at this other problem. 55 degrees Celsius equals how many Kelvin? Well, there's your formula. Temperature in degrees Celsius. Oh, there should be a degree sign. Temperature in degrees Celsius plus 273. So I'm going to substitute this 55 in for the temperature. So 55 plus 273, and that's going to equal, now I'm really hoping you actually picked up your calculator and you gave it a try, but 328 Kelvin. We are adding. For significant figures, when you add and subtract, what do you look at? Decimal places. So for a Celsius to Kelvin or Kelvin to Celsius, you do need to watch your decimal places. Watch your decimal places. Okay, let's try one more example here. And going the other way, what is the temperature in degrees Celsius if it's 465 Kelvin? Again, I'm going to substitute in for this temperature sub-degree C a variable, say x. That's not a very nice x. X plus 273 equals, and I'm going to substitute the 465 in for T sub k. 465. Well, how are you going to solve this? If you guess subtract 273 from both sides, you're spot on. And I'm really hoping that you paused the video, picked up your calculator, and gave it a try. Or you could just actually subtract it the longhand, and you end up with 192 degrees Celsius. Not too bad. Converting between the Fahrenheit and Celsius scales is not as easy. The good news is there is a formula. The bad news is, oh, well, there isn't any bad news because I'm not going to ask you to memorize it. Yay, there's once I actually say, don't memorize this. I just want you to know how to use it. You really don't have to memorize it. Here are 3 helpful formulas. The top one we just went over, the second one we saw, the third one will allow us to convert from Fahrenheit to Celsius. Please note on this bottom one, if you're referring to the formulas, the helpful formulas in your book, there is an error in your book. Feel free to find it and fix it. Well, let me know if you decide to make that change. These are the homework problems we'll be working on in class. Have a great night.